After watching this video, you would understand how to add any kind of vector. In the previous video, we discussed how to add vectors that are perpendicular to each other at 90 degrees, something like this. But what if you are having vectors that are, just anyhow? How do you add them together? In this video, we are going to be learning that. Now, let's say you have a vector, let's call it A, and it is in this direction. Let's call this 45 degrees, and this length, let's call it 10 meters. And you have another vector from here in this direction. Let's call this 140 degree, and let's call this 11 meters. And let's add another vector, let's say something like this. Let's call this 270 degree, 90, 180, 270, 270 degree, and let's say this is 6 meters. So how do you add this kind of vector together without problem? Just make a table. Distance, angle theta, the x component, and the y component. Here you have 10, here you have 11 meters, and here you have 6 meters. The theta here is 45 degrees, here is 140 degrees, and here is 270 degrees. So what is the x component? What is the y component? For this, the x component, let's call this A, B, and C. So the x component of A is 10, that is AX is 10 cos theta, and the y component, which is AY, is 10 sin theta. Remember, here cos theta is cos 45, so that is 10 cos 45, and here is 10 sin 45. So let's find sin 45, 0.7 blah 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 times 10 is equal to 7.07. So here is 7.07. The y component is 7.07. Let's come to the x component. Cos 45, we have 45, then let's say times 10, 7.07 as well, 7.07. Let's do the same thing for B, 11, 140. So Bx would be 11 cos theta, and theta is 140. Let's just write it direct, cos 140, and By is equal to 11 sin 140 degrees. So now let's look for the x component. We say 140 the cos times 11. We have minus 8.42, but this is going to be minus 8.43 if we round off. So minus 8.43 minus 8.43. Then sine 140 sine times 11, 7.07. Wow, 7.07. So for the last one, which is this Cx would be 6 cos 270 while CY would be 6 sine 270 degrees. 270 cos 0 times 6, still 0. So nothing on the x-axis. And for y, we have 270 sine minus 1 times 6 minus 6. So 0 minus 6. And if you compare all these data you have to what you have here, it kind of makes sense, because from this point you have something on the x-axis and you have something on the y-axis. If you look at this as well, on the x-axis is going negative, so we have a negative x component. On the y-axis is going up, so that's positive on the y-axis. And if you look at this, it has nothing on the x-axis. It does not go this side and does not go this side as well. And if you look at y, it is 6 and the y component is minus 6. That means all the 6 is just directed to the negative y-axis, and all this makes sense. What we are looking for is the distance from here to here in this direction. So our answer should be between 90 and 180. So let's look for the distance itself. The first thing, if you add all these x components together, it gives you the x component of this, which is from here to here. And if you add all these y components together, it gives you the y component of this, which is from here to here. Now let's use our calculator. 7.07 minus 8.43 is equal to minus 1.36. So the total here is minus 1.36. The same thing for this. We have 7.07 plus 7.07 minus 6 is equal to 8.14. 8.14. It means from here to here is 8.14. The gap from here to here is 8.14. And from here to here is 1.36 in the negative. That's why we have minus 1.36. Now, what is the magnitude? If we call the resultant D, that means D is equal to A plus B plus C. Then dx will be equal to ax plus bx plus cx, and dy will be equal to ay plus by plus cy. Now we have this data already. We have dx to be this, and we have dy to be this. How then do we get the magnitude of D itself? It is the magnitude of D is equal to the square root of dx square plus dy square. What is dx? Dx is minus 1.36 minus 1.36, and dy is 8.14. 8.14 square plus square, then in a square root. That's the magnitude of D. If you find the square of this, let's do that. Let's just say 1.36 times 1.36. That is 1.84 blah blah. So this is 1.85. 1.85. And minus times minus is plus, so we don't have it anymore. Then plus 8.14 times 8.14, and that is 66.25, which we can round off to 66.26. 66.26. Now let's add this together. This is 1 plus 66, that is 67, and if you add this together you have 1.11. If you add 0.85 and 2.6 together you have 1.11, making 68.11. 68.11. Then the square root of this is 68.11 square root 8.25. 8.25. So the magnitude of D is 8.25. Now the direction. To find the direction, we just say theta is equal to the arctan of, here is the dy over dx. Here our dy is 8.14, so we can rewrite this as theta is equal to the arctan of 8.14 over dx minus 1.36. 8.14 divided by 1.36. This is equal to 5.98, and this could be 5.99, but remember we have a minus here, so minus 5.99 minus 5.99. Let's find the arctan. So here we have minus 5.99, then let's look for the arctan. So we have minus 80.52. So our theta is minus 80.52. So let's go back to the diagram. Minus 80.52 will be somewhere around here. So this diagram is telling us that this is incorrect, but it used to happen like that because the tan of theta is the same as the tan of that theta plus 180. So the tan of 5 will be equal to the tan of 185. The tan of 10 is equal to the tan of 190, and like that. So if you are looking for the arctan, it could give any of the two. When you go through all this process, it's always good that you draw so that you are able to know whether you need to add 180 to your final answer or retain the answer you get from the calculator. So in this case, we need to add 180 to our final answer. So let's add 180. So it's going to be minus 80.52 plus 180. And that is 99.48. So theta is now 99.48. So this is incorrect and this is the correct one. So practice these questions, they will help you a lot. Thanks for watching.